Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. We are discussing the chapter atoms and molecules, and today we are going to discuss the next concept from this chapter. Atoms and molecules. In the yesterday's class, if you remember, we have talked about the molecules, right? We have talked about the ions, molecules, atoms, and etc. etc. Then we have talked about how to write down the chemical formula of any compound if we know the charge present on that ion present in the compound. So that part we have discussed in the yesterday's class. Today we are going to discuss another concept, and that is called as mole concept. Okay, in this mole concept, first of all we are going to see what is the meaning of molecular weight. Okay, molecular weight, how to find out the molecular weight, also abbreviated as MW. Molecular weight is nothing but weight of molecule, simple, right? Okay, how to find out the weight of a molecule? It is sum of atomic masses of all atoms present in that molecule. Okay, let us see one example here. Example of water molecule, right? H2O is the formula for water molecule. In H2O there are two atoms, one is the hydrogen, another is the oxygen. Atomic mass of hydrogen is 1 and atomic mass of oxygen is equal to 16. Okay, yes, therefore molecular weight of water will be equal to, as there are two water molecules, so 2 multiplied by atomic weight of hydrogen. Okay, atomic weight of hydrogen plus 1 multiplied by atomic weight of oxygen, right? 1 multiplied by atomic weight of oxygen. Okay, yes, so 2 multiplied by 1 for hydrogen plus 1 multiplied by 16 for oxygen, so it is equal to 2 plus 16, that is nothing but 18 grams. So what is the molecular weight of water molecule? Water molecular weight is equal to 18 gram. Okay, yes, so this was the simplest example. Now let us see the next example. Find out the molecular weight of NaOH. NaOH is called as sodium hydroxide. The atomic mass of sodium is equal to 23 gram. That of oxygen is equal to 16 and that of hydrogen is equal to 1, right? Therefore molecular weight of sodium hydroxide will be equal to 1 multiplied by 23 for sodium plus 1 multiplied by 16 for oxygen plus 1 multiplied by 1 for hydrogen. So it is equal to 23 plus 16 plus 1, that is equal to 40 gram. So 40 is the molecular weight of sodium hydroxide. Next example is the sulfuric acid, H2SO4. H2SO4 is called as sulfuric acid. Sulfuric acid. Okay, in sulfuric acid hydrogen is there, then sulfur is there and oxygen is there, right? Therefore molecular weight of sulfuric acid will be equal to, as there are two hydrogen, 2 multiplied by 1 for hydrogen. As there is only one sulfur, so 1 multiplied by 32 for sulfur. As there are two oxygen, as there are 4 oxygen, so 4 multiplied by 16 for oxygen. So it is equal to 2 plus 32 plus 64. So it is equal to 98 grams. So what is the molecular weight of H2SO4? It is equal to 98 gram. Okay, yes, so this is the first concept in this, that is finding out the molecular weight of the molecule. Okay, for that purpose we should know the atomic weights of the given molecules. Okay, take a screenshot of this page. Okay, now after the molecular mass, the next concept we are going to discuss, and that is nothing but mole. Okay, or mole concept actually. First of all, let us see what is the meaning of this word mole. Okay, to understand this meaning of this word mole, I'll give simple analogy. Okay, so for an example, if you go to the market and if you want to buy apple or banana, okay, so how do you ask to the vendor? That is, I want 1 dozen of apple, right? Or I want 1 dozen of banana, right? You know that in 1 dozen there are always 12 apples or 12 bananas. Okay, but if you want to go to buy a rice grains, right, or wheat for an example, in that case you will not use dozen as a unit. In that case you'll use 1 kg or kg of banana, kg of rice, right? As we know, 1 kg is always equal to 1000 gram. Okay, yes. Then if you go to buy the milk or any liquid substance in the market, you will not use kg, you will use the liter as a unit, liter or milliliter. We know that in a liter always there is 1000 milliliter, right? In a liter there is always 1000 milliliter. This is fixed, right? Okay, so what are these dozen, kilogram, gram, liter, milliliter? What are these? These are nothing but the units to express different substances. As the substance changes, unit changes, right? As the substance changes, unit changes. So we are using the unit on the basis of nature of the substance. So if I want to measure very tiny particle, okay, very tiny particle, these tiny particles we are not even able to see by open eyes. We are not never able to see these tiny particles. So for those particles I cannot use the unit dozen, I cannot use the kilogram, or I cannot use the liter as a unit, because these units are used for larger quantities which we are able to see by eyes. But to express the number of the particles which are very very small, which we are not able to see by eyes, for that purpose we are going to use the unit which is called as mole. Okay, so what is mole? Mole is just like dozen, kilogram, gram, liter, milliliter only. It is just an unit which is used to express number of particles present in the matter. Okay, so what type of particles are present? Let us see. What are the different particles which can be measured or expressed by using the unit called as mole? Okay, let us see one by one what are the different particles. So first particle is nothing but atoms. As we know, atoms are the smallest fundamental units, entities of the any matter. Atoms are very small, we are not able to see them. After atom, the second is molecule. Just like atoms, molecules are also not visible. Okay, you can see the compound, right? You can see the water, a glass of water, you can see water in it. But if I ask you to separate one single molecule of water from it, it's not possible, because it is very very tiny, very very tiny. Okay, yes, molecules are also there. After molecules, the next is ions. Okay, ions are also we are not able to see. So what are ions? Ions are when there is charge present on atom, that is called as ion. Okay, ions are of two types. One is called as the cation. Okay, cations, and another is the anions. Okay, another is the anions. As we know, cations have positive charge on them, anions have negative charge on them, right? So ions are also measured by using the unit called as mole. Okay, then next, after this, if we want to measure the subatomic particles, okay, if you want to measure the subatomic particles. Okay, so what is the meaning of subatomic particle? These are the particles present in atom, inside atom. So subatomic particles are smaller than atoms. Okay, so they are the smallest, you can say, subatomic particle. That's smaller than atoms. So what are the different subatomic particles? Let us see. So first is protons. Then next is neutrons, and the third one is electron. So these are also small particles which we cannot see by open eyes, and therefore to express their number, express their amount, we are going to use the unit called as mole. So what is mole? Mole is simply the unit used to express the quantities of or number of particles of these many small tiny particles, right? Do you understand what is the meaning of mole? Okay, so just like in every dozen there are 12 in number, 1 kg is always 1000 gram, 1 liter is always 1000 ml. Similarly, this mole is also having one fixed number in it. Okay, what is that? 1 mole of particle, 1 mole of any particle, particle means all these atom, molecules, etc. 1 mole of any particle is always equal to 6.022 into 10 power 23 particles. Okay, when I say 1 mole of particles, in that 1 mole, just like in 1 dozen, 12 banana are there. Just like in 1 mole, how many particles will be there? 6.022 into 10 power 23. Do you imagine? This is really a very big number. Okay, now this number was given by one scientist. The name of this scientist is Avogadro. It is given by Dimitri Avogadro. Therefore, it is called as Avogadro's number. Okay, this number 6.022 into 10 power 23 is called as Avogadro's number. It is denoted by capital N and capital A to the subscript. N stands for number, A stands for Avogadro. Okay, so when I say 1 mole, 1 mole of any particle, 1 mole of any particle is always equal to 6.022 into 10 power 23. Okay, yes. So just take a screenshot of this page and then I will explain the next concept from this topic. Okay, now this was about the mole, the meaning of the word mole. Okay, now let us see some examples so that I can explain what is the mole to you. Okay, and one more thing, I'll write down here. 1 mole of an atom, 1 mole of an atom is equal to Avogadro's number, that is we have already written 6.02 into 10 power 23 atoms. It is equal to its atomic weight. It is equal to its atomic weight. Okay. Similarly, 1 mole of a molecule, in 1 mole how many molecules will be there? 6.022 into 10 power 23. These many molecules will be there, and 1 mole is nothing but its molecular weight. Okay, 1 mole is nothing but its molecular weight. Okay, let us see some example here. So first of all, if I write down 1 mole of carbon atom, 1 mole of carbon atom. Okay, so this 1 mole of carbon atom is equal to Avogadro's number of carbon atom, that is 6.022 into 10 power 23 carbon atoms. Okay, carbon atoms. Similarly, it is equal to its atomic weight. Atomic weight of carbon is 12, so it is equal to 12 gram of carbon atom. Okay, it is equal to 12 gram of carbon atoms. Okay, then next example, 1 mole of hydrogen atoms. 1 mole of hydrogen atoms, it is equal to 6.022 into 10 power 23 hydrogen atoms. Avogadro's number, right? Hydrogen atoms, and it is equal to its atomic weight. Atomic weight of hydrogen is 1, so it is 1 gram of hydrogen atom. 1 gram of hydrogen atoms. Okay, then in general we can write down 1 mole of any particle. Okay, any particle means it can be atom or it can be molecules. All the particles which I have listed, it can be ions or it can be subatomic particles. Okay, it can be subatomic particles, that is proton, electron, neutron. These are the subatomic particle. Okay, yes, for them also the same analogy. It will be equal to 6.022 into 10 power 23 number of that particular particle. Okay, of that particle, it may be atom, molecule, ion or subatomic particle. Okay, and it is equal to its relative mass. It's here I am using the word relative mass because it's combination of atom and molecule and ion, so relative mass is a common word for them. Relative mass of those particles, relative mass of those particles in grams. Okay, like for example, if it is an atom, its atomic weight, its molecule if it is molecular weight. Okay, then last thing, 1 mole of molecules. 1 mole of molecules will be equal to again Avogadro's number of molecules, 6.02 into 10 power 23 molecules. It is equal to, as it is molecule, it will be its molecular weight or molecular mass. Molecular mass in grams. Okay, yes, so these are the tricks you need to remember. Okay, just take a screenshot of this page. Okay, now let us see some question based on this mole concept. Okay, questions which are asked in the exam. First question, calculate the number of moles in 52 gram of He. Okay, 52 gram of He. Okay, now H is nothing but helium, right? H is nothing but helium. Now helium is a noble gas. Okay, so noble gases are monoatomic molecules, right? Monoatomic molecules. Okay, if you remember, we have seen about atomicity in the last class. That is, noble gas, they have very stable configuration. They do not want to form any compound with other elements, so they remain bachelor. They do not marry anyone. So here same happens with the helium also. Helium is also one of the noble gas. Okay, so here you can see the weight is given, right? And we have to find out the number of moles. So some formulas I will be writing here. Just remember these formulas. So first formula is number of moles. Okay, number of moles of, here as it is molecule, helium gas, right? If they have written atom in front of it, then that will be molecule. Now in case of helium, there is no question actually to worry about, because it is monoatomic in nature. So number of moles of molecule will be equal to given weight. These are very important formulas. Okay, given weight divided by molecular weight, right? Given weight divided by molecular weight. Both of them should be in grams, right? Both of them should be in gram. Okay, now let us see what do we have. Okay, so here given weight as given weight of the substance given is 52 gram. Then molecular weight, or which is also called as molecular mass, or it is also called as molar mass, another word for molecular mass. Molar mass of helium is equal to 4 units. Okay, 4 grams I'll write down. Okay, then actually for helium, atomic as well as molecular mass are same. Okay, then let us see. Yes, symbol for number of moles is small n. Okay, therefore we will write down number of moles will be equal to given weight is 52 gram, molecular weight is 4, so it will be equal to 13. So what is the number of moles of helium in 52 grams? 32. Okay, 13. Okay, so 13 is the answer for this question. Okay, yes, so this is the first type of formula. Number of moles is equal to given weight divided by molecular weight for molecules, atomic weight for atoms. Okay, then next question we can discuss now. Again, calculate the number of moles. Calculate the number of moles. Calculate the number of moles in 12.044 into 10 power 23 number of He atoms. Number of He atoms, helium atoms. Okay, so here number of atoms are given. We have to convert it to number of moles, right? Okay, now what we know here as 1 mole of atom. 1 mole of atom is equal to what? 6.022 into 10 power 23 atoms, right? Now the same thing I can write down for helium also. Therefore, for helium, therefore 6.022 into 10 power 23 10 power 23 helium atoms, He atoms, that is helium atoms, is nothing but it's 1 mole, right? Is nothing but it's 1 mole of He atom, right? Okay, so therefore in these many number, how many moles will be present, right? For this number 1 mole, for this number how many moles? So we can do the cross multiplication. Therefore 12.044 into 20 10 power 23 He atoms means how many moles? We can do the cross multiplication. It is 1 into 12.044 into 10 power 23 divided by 6.022 into 10 power 23. So it will be equal to what? 10 power 23 will be cancelled out, and 12.044 divided by 6, that means 2. So what is the number of moles of helium atom here? Is equal to 2 number of moles. Okay, yes, so this is how we can find out the number of moles by using the formula. The two different questions for the same number of moles I have explained to you. Take a screenshot of this page. Okay, I hope you have taken a screenshot. Now we will stop here only for today. Then before ending the class, let me just show you about DPP, daily practice problems. So this is a teacher's portal. You have to go to resources, then to writing material, then you are going to see the DPP here. You are going to write down the solutions of all questions on notebook, take a photograph of it and upload the photograph on your portal. So teacher will evaluate it and let you know the corrections or suggestions wherever required. Okay, so that's all about DPP. I hope today's session, you understood today's session. If you have any questions about today's session in your mind, you can just note down those questions and let me know the questions in next session. Okay, so thank you so much students, and all the best to you, and take care.